Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geek for Geeks for 5th February 2023. The problem statement for today is intersection point in Y-shaped linked list. This is based on linked list data structure and this has been asked in many companies like VMware, Flipkart, Ecolite, Amazon, Microsoft, Snapdeal and many more. So let's start this problem statement. So here we'll first read the problem statement. It is saying that given two singly linked list of size n and m, write a program to get the point where two linked lists intersect each other. So basically we need to find the intersection point for the two linked list where they are actually merging. So for example, two linked list has been given as 369 and it is referring to the common, and in linked list 2 also after 10 it is mentioning to the common, and for common it is 15 and 10. So actually the input will be only two linked list where this common is referring to this third line where it is 15 and 30. So if you look at the actual question, that actual linked list, it will be look like 3, 6, 9, 15 and 30, and for the second linked list it will be like 10, 15, 30. So this two linked list will be given and we need to find the intersection point where these two linked list is actually getting merged. So whatever is the data for that linked list, that we need to that particular node that we need to return. Let's look at this second example. So here also a similar type of thing. Here it is linked list 1 contains 4, 1 and common part. Linked list 2 contains 5, 6, 1 and common part. And common part includes 8, 4 and 5. So the given linked list will be of the size 5 for the first one and for size 6 for the second one, and this will contain elements like for linked list 1 4 8 4 4 1 8 4 5, and for the second one it will be 5 6 1. Then this part will be common where it consists of elements like 8 4 and 5. So here also this becomes the that intersection point. So we will try traversing this linked list and we need to we'll find that what is the intersection point where both the linked list actually meets. So let's try solving this problem. So what we can do here, first we can assign this one to a node variable of type current one. I'll give it to head 1. Then for second type it will be node current 2 to like head 2. So I have just initialized two variables called current 1 and current 2 with these two nodes which has been given as an input, and these are actually the head node for the given linked list. And what we will try, the approach we will take here is that we will try traversing one of the node completely, and we will keep storing the particular node in any data structure we can call either linked list or either list or set. So we can store them in a set. Then while traversing the second linked list, we can check whether if that particular node is present in that set or not. That means in the set we will be storing the element of first linked list, and while traversing the second one we'll keep checking whether the particular node from the second linked list is already present in that node in that set or not. And if that is present, if we find that anything from linked list 2, this node 2, this linked list 2 is present in linked list 1, so that moment we will return that data of that particular node. And in all other scenario where we do not find any merge, in that case we need to return -1. So this approach only we will be just writing it through code. So what we can do here, I'll first try to initialize one set of type node. Let's give it a name as set only, and we can create a hash set hash So we have created a variable which is a hash set of type set. Okay, so now what we can do, we start our traversal for first linked list, and first linked list is now we are pointing to the first linked list with this variable name, which is current one. So we can continue this traversal when till the point the value of current one is not equal to null. That means until it reaches the last point, we'll try iterating this linked list, and we'll keep on adding it into set, where we'll be keep on adding this node to the set. And after that, once we add that particular node, we'll increment, we'll point this variable current node to the next of current node, current one dot next. So since this is pointing to the current one is pointing to the head, so first we are storing head here, then we are updating the value of this head, or we have initialized with current one, so we can say it current one with the next of current one. So this way, this is the generic way, the way we do a traversal in linked list. Now, so now after this point ends, that means till this point this while loop exit from this one. So we will have all the nodes of linked list 1 is stored in set of this one, this set of nodes whatever we have created. Now we will start our iteration for linked list 2, which we have pointed through variable current 2, and again we will go for it as well, saying well current 2 is not equal to null. So here we will just check if this particular node is present in the set or not. If set dot contains, we can check this node, which is current 2. If this is true, then we can simply return current 2 dot data. And if this is not correct, that means if set doesn't contain this particular node, then we can simply look for the next node, and for looking to the next node, we need to just update the value of the current 2 to current 2 dot next, current 2 dot next. So this part is done, and if we do not get any return from here, that means if set doesn't contain any node from second linked list, that means this condition becomes false in each iteration, then at last we can conclude that there is no merging point for two linked lists, and in that case we can simply return -1. So we are pretty well done with our codings. We'll just go through what we have done. We have just initialized two variables of node type, and with head 1 and head 2, and I've created a set which set to store all the nodes from the first linked list. So for that I have initialized this one, and I'm checking that whether I'm taking till the point the current becomes null. That means we reach the end of the first linked list. So till that point we keep on adding that particular node to the set, and keep on incrementing the value of that particular node. That means we keep on pointing to the next node. So for that we use current 1 dot next. So once this is done, then we start with the second linked list, and for each node we check whether that particular set contains that particular node or not. And if we find that particular node, so we can conclude that that is the intersection point, and we return that data of that particular node, where that is supposed to be the intersection point of both the linked list. And for iteration also, here each time we point to next of current node, that is here current node is current 2, so we point to next of it. And if this condition doesn't satisfy, then we return -1, saying that there is no intersection point. So now let's try compiling this code. Okay, so we have got this answer correct. So let's try submitting it. Okay, so here you can see we have cleared all the test cases. So this problem is solved completely. So yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.